The Copernicus understanding of a sun-centered universe set in motion a series of further discoveries and theories, arguments and claims about the relationship of the Earth to the universe that, as we've seen moving through Tycho Brahe and Johannes Kepler, Galileo and Isaac Newton, together marked a new era in European history that some historians have called the scientific revolution. It's a revolution because it's not just about understanding the relationship of the Earth to the universe or the movement of planets around the sun. It's a revolution because it marks a new way of thinking about reality and a new kind or a new expression of social power. We see for the first time the emergence of a group of people who begin to call themselves scientists. They begin to communicate with each other, publish journals, they send letters to each other, they compare notes, they develop friendships. A new kind of fraternity emerges among these scientists, and they are people who can claim power. Kings want to attract them to their courts. They have a new kind of knowledge that proves to be very powerful and very useful. And it marks, the European or the medieval understanding of social groupings is divided into the aristocracy, the clergy, and the peasants. Well, now we have some new groups emerging. We saw in the Renaissance the merchants emerging as a new social group, and here in the scientific revolution we have the scientists emerging. They are powerful because they bring the new approach to knowledge that we know today as the scientific method, in which you begin by asking a question, you do research, you construct a theory or hypothesis that needs to be tested, and then you keep careful record of your tests, of your results. You compare those with what you anticipated, and if your theory proves true, then you report it and you can claim to have advanced knowledge with what you've discovered. If it's not true, then you start all over again. But this becomes a very powerful approach to cumulative knowledge, so that once a scientist proves something in the laboratory, it can be shared. If it's done in a trustworthy way, you don't have to relearn it all over again. This is maybe in contrast to what happens among philosophers or ethicists, where the knowledge that they gain seemingly needs to be relearned by every generation. Scientists, mathematicians, this new class of thinkers regard knowledge as cumulative. It also marks a growing tension in which the authority of reason becomes more and more explicitly set over against the authority of the church and the authority of faith. We know this tension in the modern world with the public debates over atheism, the question about secular humanism in schools, whether there should be a place for prayer in public schools. All of these are tensions, in part because the scientific revolution left in its path the idea that reason is public knowledge accessible to everyone, whereas faith is particular knowledge. Faith has to do with opinions. It's not to be you can never fully resolve theological debates, whereas scientific debates can be resolved, and so reason becomes a public authority. From the theological perspective, we saw this already as a consequence of Copernican thought. There is a new awareness that the Earth may actually be a fairly minor planet in a huge universe, and a new understanding of God as an impersonal God, as God at best who was a creator of the universe, set it in motion, but no longer necessarily is actively engaged with the affairs of humanity. All of these are consequences of the scientific revolution that didn't emerge immediately. But by the end of the 18th and the beginning of the early 19th century, they're coming into focus, and they point a direction for the modern world.